Today we will talk about cardiorespiratory fitness. Cardiorespiratory fitness is the ability to perform large muscle, dynamic, moderate to vigorous intensity exercise for a prolonged period of time. Today I will show you two different methods to evaluate VO2 max in a submaximal level.
The equipment we will need is paper and pencil to record data, a stopwatch, a scale, and you need to be located in a track or a playing field. Optional, a heart rate monitor.
When doing a submaximal exercise test, um, usually it's on a field-based test for the reason that it's not always feasible to do a test in a medical settings. This submaximal test is usually used to predict VO2 max as a relationship to workload. Okay, we will show you two different tests. The first one is a Cooper 12-minute test. It consists of a 1.5 mile run in a 12-minute period. And we will also be showing the Rockport 1 mile fitness walking test.
To have an accurate VO2 maximal exercise test, the following criteria should be true. A steady state heart rate is obtained for each exercise work rate. A linear relationship exists between heart rate and a work rate. The difference between actual and predicted maximal rate is minimal. Mechanically, efficiency is the same for everyone. The subject is not on medication, using high quantities of coffee, under large amount of stress, ill, or in high temperature environment at which may alter heart rate.
Before we start the test, we need to make sure the subject is warm up to stimulate the blood flow in the body, as Ricardo is going to demonstrate right now. He's going to start with some stretches and then a little dynamic warm up. On males, they need to make sure to run for at least 8 minutes the mile, and females will have to run at least for 9 minutes at his own pace.
As soon as the subject finishes the running test, we need to take the heart rate. If you do not have a heart rate monitor, you can take your heart rate by placing your two of your fingers on your wrist on the radial artery, or you can also take it with your carotid artery by placing your two fingers pressuring for 15 seconds and count all the heartbeats. After that, you need to multiply by 4 and you will have your total heart rate per minute. You can also use a walking test for which the subject needs to walk comfortably at his fastest pace. Once again, as the subject approaches, you need to make sure to take the time, and you will also have to take your heart rate.
We need to make sure that we can take our heart rate, our pulse. You can usually do it at your wrist, counting for 15 seconds the pulse and multiply by 4. You can also do it in the carotid. Same protocol. Count for 15 seconds and multiply by 4.
Since we have finished our protocol, now we need to make our calculations in order to find the VO2 max for each of the tests. You can see there's two equations that we need to use that they are located in this table. They are the first two, the one for the jogging for 1 mile, and the other one is the 1 mile walk. Now that we're finished, we can go ahead and calculate the VO2 max with either our jogging or walking test. We're going to talk first about our jogging equation. The VO2 max equals 100.5 minus 0.1636 times kilograms of the body weight minus 1438 times the time it took for the subject to run the laps minus 0.1928 times the heart rate at the end of the protocol plus 8.344 times 1 if it's a male or times 0 if it's a female. The walking equation that we need to use in order to get the VO2 max is the following. VO2 max equals 132.853 minus 0.0769 times the body weight in pounds minus 0.3877 times the age in years plus 6.315 times 1 if it's a male or times 0 if it's a female minus 3.2649 times time in minutes minus 0.1565 times heart rate beats per minute. Now that you know the VO2 max, you can start elaborating the exercise regimen for this subject.